So in this section, we're going to look at the angle side triangles or angle side angle. We're also going to look at the side angle or angle side, right? So SSA or ASS, depending on how you want to look at it. And what we run into is what's called the ambiguous case. So this is the triangle that you have to be aware of, right? Like this spells out backwards ASS. You have to be aware of the AS triangle because based on what you're given, right, you're giving an angle and then two consecutive sides, right? Based on what you're given, it's possible to have exactly one triangle like you see here, right? This triangle ABC where all the sides connect, right? But look at what happens. If I change the length of this side, right, if instead of being given a 20.3 side, I'm given a shorter side, right, look what happens. I have no possible triangle, right, because this third side is too short and it won't connect. Okay? Now, the other thing that you have to be aware of is that while sometimes it's possible to have two different triangles, right? So if you look at this dotted red line here, right, you can have triangle ABD, right, based on the information given. If you're given that this side over here, this length AB, that segment has a length of 20, and the length BD is 13.4, and this other angle here is 40, it's possible to have this red triangle here. It's also possible to have triangle ABC, okay? And, right, it still meets the same criteria. You have a 20 unit side, the next side is 13.4, and it has this given angle of 40 degrees, okay? This comes from using the inverse sine, right? When you use inverse sine to solve for an angle, remember what we talked about today, that it's possible to have two solutions. Okay, in fact, almost always, except for one case, there will be two solutions. And based on the information given, it's possible to have two triangles. So in a couple of videos, maybe not the next one, but the following one, I'll actually work out a problem so that you can see that based on the information given, it's possible to have two triangles. But I do have the link to this applet posted in Web Access so that you can play around with the different variations of angles and see what happens when you change the length of the sides. Okay? So be aware of the AS triangle.